So now the first year IT student, and now we are going to see the fourth unit, that is optical properties of materials. First question: explain absorption and emission of light in metals. Insulator and semiconductor. So metal nothing but conductor. So the meaning of this question is how the light is going to be absorbed and emitted by the metals, insulator and semiconductor. First we are talking about the metal. In metal, how this absorption taken place. In case of metal, there is no energy gap between the valence band and the conduction band. The energy band, that means valence and conduction bands are overlap each other. So in this case of metal, the electrons are occupied like this level. So now this is being named as energy, that is Fermi energy level. Fermi energy level is a energy state above which there is no electron is occupied. Fermi energy level is a energy state above which no electron is there. In case of metal, when some light is incident, suppose the light whose energy is equal to h nu is incident on that metal surface, then this electron is moved from this state to the higher state, that means over that Fermi energy state also. So this is the absorption takes place in case of metal. So in case of metal, the result of absorption, the electron which move from one level to the higher level, that is over that Fermi energy level. So that is absorption in case of metals. Similarly, in case of metal, how the emission is possible? The emission is possible from this. That means these are the energy level. This is the Fermi energy level. Then here that higher energy state. So due to absorption, so here fully the electrons are occupied. Due to absorption, some electrons are moved from this lower energy to higher energy state. So here the vacancy is there, that we called hole. The hole is there. So now, in the case of emission, the electron which is jump from the higher energy state to this lower energy state. As a result of that, emission will be taken place in case of metal. So this is a method of absorption and emission that taken place in metal. Further, the metal have an ability of, that is reflectivity. The reflectivity of metal lies between 0.90 and 0.95. Reflectivity of metal is between 0.90 and 0.95. So this reflectivity. So what is the need of this reflectivity? Already explained how the absorption taken place and emission taken place in case of metal. Particularly some metal which is able to absorb the light and also emit more or less all the light is going to be fall on this metal is going to be reflected based on this reflectivity. So this means 0.95 means 95% of light is going to be reflected back. So some some metals. So the high reflectivity material is like aluminium. Aluminium whose reflectivity is high, that is nearly 95% light is going to be reflected. Some other metal whose reflectivity is less, so that all the light which is fall on this metal is not completely reflected back. Some amount is going to be that is scattered inside this metal. Scattered inside this metal after the absorption. This scattering is divided into three different types. That is the first one is Rayleigh scattering. Rayleigh scattering. The second one is that is Tyndall effect. So the different type of scattering is also possible in the inside the metal based on the reflectivity. Rayleigh scattering, which clearly explain the low wavelength light is going to be scattered very much. So the Rayleigh scattering, which explain that scattering is inversely proportional to the wavelength of incident light. So lower wavelength light is scattered very much comparing the higher wavelength. Then Tyndall effect also, which explains that the low wavelength light like a blue is going to be scattered very much and the higher wavelength is going to be absorbed is going to be absorbed. So these are the different method of scattering also. Scattering, that is Rayleigh scattering, Tyndall effect, to explain about this scattering. And also further another one scattering is there, that is Compton scattering. Compton scattering, which is explained about the scattering of light like that is higher wavelength light, gamma ray and also X-ray. So these are about the absorption and emission of light in the case of metals. Then now we move to this insulator. So in this case of insulator, there is a definite energy gap. There is a definite energy gap between the that means valence band and conduction band. There is a energy gap between the valence band and the conduction band. So this energy gap is denoted by E. When some amount of light energy whose value E is equal to h nu is fall on this insulator, that means insulator, as a result of that this amount, that means electron that is available in valence band that move to the conduction band, as a result of that the absorption will be taken place. The condition is that the energy of incident light h nu, which is greater than energy gap. If the incident light energy which is greater than energy gap, then it is possible the absorption. Similarly, the emission will be taken place when the electron that jump from the conduction band to valence band. There is a formation of, when the electron jump from valence band to conduction band, here the hole will be created, here the electron is there, so hole electron recombination will be taken place. As a result of that, the absorption will be taken. Similarly, when electron that is available in the higher state, that is conduction band, come to the valence band, there is a possibility of emission of light, and that we called emission. That is emission in case of insulator. The very important point is the incident light energy which is greater than energy gap. Then only the absorption will be taken place. So after the absorption, there is a possibilities of emission if that is the incident light whose energy greater than that of the energy of electron which is occupied in the conduction band. Automatically the electron from conduction band that come to the valence band that emit light. that is insulator. Now we move to the that is semiconductor. In case of semiconductor, that is semiconductor actually that classified into two different types, that is intrinsic semiconductor. The second one is extrinsic semiconductor. In intrinsic semiconductor, as usual, the process will be taken place. There is that is valence band and conduction band. In between that, the energy gap is there. This energy gap, when the that means when for energy, that means incident energy fall on it, some amount of some electron that move from the valence band to conduction band. So here the hole will be created, here the electron is there, so hole electron combination that produces. This is a way of the emission absorption taken place in case of intrinsic semiconductor. Then in the case of extrinsic semiconductor, in case of extrinsic semiconductor, actually extrinsic semiconductor, the two different types are there, p type and n type. P type semiconductor and n type semiconductor. In p type semiconductor, look at this diagram, this is a conduction band and here it is a valence band. In case of p type semiconductor, one energy level is there, that is acceptor level, EA, acceptor level. Similarly, in case of n type semiconductor, this is a valence band, conduction band, and one level is there, that is donor level. So here this emission and absorption taken place based on the acceptor energy level and donor energy level. In case of n type semiconductor, the donor energy level that lies just below this conduction band, and in case of p type semiconductor, a level is there, that is acceptor energy level just over this valence band. The transition taken place between these levels result the absorption and the emission of light that is taken place in case of the semiconductor. So these are the method of emission and absorption of the light, which is fall on the different categories, that is metals, that is conductor, insulator and the semiconductors. So this is a conclusion. So very easy, metal, how that emission and absorption taken place, that is the help of this Fermi energy level. And in the case of insulator, that is normal case between the valence and conduction band. In case of insulator, that happen normally in the intrinsic semiconductor, and particularly the p type and n type semiconductor, the transition will be taken place based on the that is acceptor energy level and donor energy level. Why it is donor level? Because here the excess of electron means that is ready to give electrons, so that is a donor level. Here the holes are excess, majority carrier is hole, that ready to accept electron, that we called acceptor energy level. So based on the transition taken place in these levels, different energy levels, the emission and absorption of light that taken place in the case of the semiconductor. So this is the answer of the first question. So we will see the answer of the second one in the next videos. Thanks.